So hello, assalamu alaikum. My name is Madhav, and today we are going to talk about the types of vectors in physics. So today we'll talk about how many types of vectors are there, what are the definitions, and what are the examples. Okay. So firstly, we have equal vector. So basically, it means that if the magnitude, unit, and direction are same, so it's called equal vector. So basically, if you have the magnitude, direction, and units same, so it is said to be equal vector. For example, I have vector A, which is 2 meter long, and we have vector B, which is also 2 meter long, and their both direction is east. So it is these both are said to be equal vector. Okay. Second, we have parallel vector. Okay. Parallel vector. It says that it doesn't matter whether um, whether you have different unit and magnitude, but direction must be same. Direction must be same. Okay. So what does it mean? Like, for example, I have a vector here, vector A, which is 5 meter long, and I have vector B, which is 2 meter long. Okay. And what we say, 2 meter long. So here, as you can see, their magnitudes are different, units can be different, like centimeter. I put here centimeter, 5 meter, so units are different. What we say, units and magnitude are different, but the direction are same, so it is said to be parallel vector. Okay. Para I written wrong. Parallel vector. Okay, so this is parallel vector. Third, we have anti-parallel vector, the opposite of this, opposite of how it can be opposite of this. For example, it same as here, it doesn't matter that you have the same unit or different unit by the other vector, but the direction must be different. Direction must be different. Must be different. Okay. For example, you have, for example, you have a vector A, which is 5 meter long, and you have vector B, which is uh, 2 newton, for example. Okay. So it doesn't matter that the units are different and the magnitude are different, but the thing is that the directions are also different, so it is said to be anti-parallel vector. Anti-parallel vector. Okay. Fourth, we have negative vector, which is very important. So what does it say? That basically negative vector says that if the magnitude and unit are same, and direction is opposite, so it is a negative vector. So it is negative vector. What does it mean? That I have a vector A here, which is 5 meter long, vector B here, which is also 5 meter long, so it is said to be parallel vector. Oh, sorry, it can be here. Okay. Direction must be changed. Okay. In this case, it doesn't matter that you have a different unit, different magnitude, but in this case you must have the different, you must have the same unit and what we say, units and magnitude, but they must have the opposite direction. So we got that. Okay. Negative vector. The sixth we have, which is very what we say, important, collinear vector. This is a completely another vector, but some people, I don't know why they merge this vector to this some other vectors as well. So it does mean that all vectors of same direction lie lie on a same plane, lie on a same line. Okay, so what does it mean? If I have a vector a here and vector b here, so it cannot be counted. Okay, these are wrong. But if we have the vector a here, then we have a vector b here, then we have a vector c here, so these are right. Okay, and it doesn't matter that how much, like what we say, what is the magnitude of these, what are the units of these, like for example 2 meter, 5 newton, 7 centimeter, it doesn't matter, but the vectors lie on a same line. Okay, so these were this is the definition. The seventh vector that we have is um seven vector seventh vector that we have is coplanar. Cople coplanar. Okay, coplanar vector. So what does it say? It is the same as the collinear, but totally different. As we talked about that, the vectors should be lie on a same plane, same line. But in this case, vectors must lie on a same plane. All right. So what does it mean? For example, I have a plane here. Okay, this is a vector, this is a vector, and again this is a vector, so it is white. Okay, if I put this vector, for example, like right here, so it is wrong, otherwise it is right. So this is the coplanar vector. Okay, and it must be in 2D direction. As you can see, it is in 2D direction, for example. Okay, the eighth vector that we have is unit vector. Okay, the unit vector, in this case we only have one magnitude. Okay, and we have two things. Firstly, let me write the definition. Magnitude, and it is denoted by a cap, or you can say a cap. For example, it doesn't matter that there's a small letter or capital letter, it should be the cap on it. It is cap, and the formula, or you can say, to find the unit vector is a cap is equal to a vector, the original vector, and the magnitude of that vector. Okay, for example, if I want to find the, so I have a vector, for example, um, first of all, leave it, I'll give you the example in the last. Okay, this the ninth vector that we have is null vector. Okay, so null vector, so what does it mean? In the null vector, as you can, if you have guessed already, very good. If not, so let me tell you that in null vector you have zero magnitude. It does not have any magnitude, but it can tell the direction with the any arbitrary direction, with any arbitrary direction. Okay, any arbitrary arbitrary direction. It does mean that it it doesn't have a specific direction, but it tells the direction in any orbit. For example, I have a dot here, so you can say it is telling the direction to the east side, to the north, to the west, to the south as well. So you cannot see that it is only the showing to the east side. No, so that's the thing that that's why it is called, it is telling the directions. Okay, the 10th vector that we have is maybe I missed the numbers. Oh yeah, yeah, yeah. It was five. Then I wrote seven, six, seven, eight. Okay, this is nine. So it is free vector. In the free vector, you must have the same magnitude, unit, and direction, but the position of a vector must be different. But position must be different. For example, I have a plane here. Okay, you can see I have a plane here, and these are the, okay, these are called the coplanar vector, as we discussed previously. But if I write here this line, so it is called the free vector. because this is the same line, it has the same magnitude. The diagram is not showing the same magnitude, but still 5 meter 5 meter, it is the same magnitude, same direction, what we say, same unit, same direction, same magnitude, but the position is different. Okay, it can be also here. So the direction must be same, magnitude must be same, and obviously the vector is also the same, so it can be called the free vector. The tenth vector that we have is position vector. So to find the position with respect of origin, with respect of origin. So these are the types of the vectors. I hope you understand all the types of vectors, and thank you so much. We'll meet you in the next video. Thank you.